This video was for just 2 questions that was asked. This is the first multiple choice question that was asked, and we wanted to find the range. Which of the following would be the range of the following function? And I know that in the notes for these two, arccos plus arcsine in your textbook, it says pi on 2 is what these end up being. However, we just got to realize that also with this, that each of them individually have a domain from -1 to 1. So, for example, cos, when we did that graph, we restricted it. Remember, it was the inverse of this kind of section. So we ended up with that kind of graph and whatever it looked like, but it went from -1 to 1 when it went up from 0 up to, of course, to pi up, going up on the as its range. Okay, this is not drawn very good. And arccos was the same, right? It did this kind of thing, but it was from -1 to 1 as well. So straight away for our restriction, we just got to realize that the domain for inputting x has to be from -1 to 1, or we'd get our error for that. So at the end of the day, this means that we'd simplify this to f of x is equal to pi on 2 plus arctan of x, such that x is an element of from -1 to 1. So that's probably where the error is, because then, of course, when we're looking at our graph, and yes, our arctan function, which is, I guess, again, the inverse of that, which we know is that kind of graph, is restricted from -1 to 1. Okay, as its domain. Yes, it's also shifted up pi on 2 as well. So we want to find what is arctan at -1, and then shift it up pi on 2, and then what is arctan at 1, and then add pi on 2 to that. So that's where we get our answer for that, which is pi on whichever it was. The second question was to sketch a graph of, it was 2 marks by the look of it, sketch the graph of 2 absolute value functions. Maybe I'll look at these graphically and put the grid on, and then I guess algebraically as well. Two methods of doing this. So if I want to sketch it graphically, let's have a look and see. May as well not go that low, because, sorry, I'm just being very messy in the morning. So I don't have my drawing tools with the new update of OneNote. But the first one is the absolute value of x plus 2, and we know that this could just be graphing our x plus 2 function, which would be like this, of course, from -2 to 2, and then reflecting any part that would be underneath the axis going up. So that would be our graph of the absolute value of x plus 2, and then plus we want to find the absolute value of x minus 2, which again would be our x minus 2 graph, and then reflecting that up. So that would be like this, and then instead of going down there, it comes up that way. And we could then add what these 2 graphs are together going along. So, for example, if we have just going through different values of x, you could see that, I could put it in red, that just say x was over here, maybe it's -4, it would be 2 up plus, that should be at 2, 4, 6 up, so that should be, adding these together would be at 8 up, and then you know, if x was -2, it would be 0 plus that. And, you know, if x was -3, it would be 1 plus 2, 4, 1 plus 5, so it'd be 6 up, and so forth. So that would be the first kind of section of the graph. And then the next section's going between this cross and this cross before the next turn. We'd obviously add up these, like 1 plus 3, which is 4, and 2 plus 2, which adds up to 4. This one would be 1 plus 3, and so forth. So this section would go along there, and then the last one would do the same as the right-hand side, which would go up again twice as fast, and we'd end up with a piecewise function that is this one here. Looks like it's got a gradient of -2, and it would continue. So it'd be this piecewise function here would be like y is equal to -2x kind of graph if it kind of continued. For that kind of piecewise function for that part of the domain, this would be our graph of just y is 4 up going along for there, and then this one here would be our graph of y is equal to 2x for this kind of piecewise function. That's what it would look graphically, because it just says sketch the graph, and you might be able to, you know, it doesn't ask you to actually say the outcome as an algebraic statement. However, let's have a look at it algebraically if it did ask that, which is recognizing that f of x is two functions. We recognize that x plus 2, the absolute value of x plus 2, has kind of two sections. It splits up into x plus 2. We know for this section here, for x is greater than or equal to -2. And then it's also, of course, the negative of x plus 2. So minus x minus 2. So this section here, for x is less than 2, -2. And then the other part of the graph was, of course, the x minus 2 for this section, and the minus x plus 2 for the other component. And we recognize that by looking at these differences in the domain, there is 3 different sections for this. So if we are going across the number line for our f of x, we recognize that that's got 3 different parts. The first part is when x is less than 2, which is going to be a combination of this part plus x is less than... No, sorry, I'm wrong. The first part is when x is less than -2. X is less than -2, which is this part plus this. So it's the minus x minus 2 plus minus x plus 2. So that would be the first part of the graph, and that simplifies to minus 2x as this, because the minus 2 plus 2 cancel out. So I'll rub that out and write minus 2x. Oops. The second part going along the number line, along here, is you can see that we went from -2, and that's from -2 up to 2. Okay, so for the next part, it's when we're using this part for the first absolute value part, okay, of this line. So of this line here, we're using the x plus 2 section, and for this graph here, it's still x is less than 2. So we're going to use that part, the bottom part there. So we've got x plus 2 for the top part, plus, and then it's still the bottom part of this, so minus x plus 2. So this is when, of course, this is for when -2 is less than or equal to x, which is less than 2. in that sections, and of course these x and the minus x cancel out, and then we've got the 2 plus 2, which is 4. So that's why we end up with 4 for that little part. And the final section for this is, of course, the last part of the domain, which is when x is greater than or equal to 2. And you can see for this graph, it's when we've got the positive for both of these absolute value functions. So when this one is positive for when x is greater than or equal to... Oh, I'm looking at the wrong one. Greater than or equal to 2, and also this one here is also positive as well. So we end up with x plus 2 is the one used there, and then x plus x minus 2 is the other graph. And these ones add up to x plus x is 2x, and then plus 2 minus 2 cancelled out. So we ended up with 2x for that part of the domain. So that's why it's a piecewise function that is negative 2x for x is less than negative 2. It's 4 for those values in between, and it's 2x for the upper section algebraically, looking at those. Okay, so that were the two questions asked there.